Okay, thanks everyone for coming. This is a session on Go. If some of you know Go already, it might be a bit boring. It's basically my journey over the last year in looking at Go and the issues and joy I had over that year. So my name is Paul Bouwer. I'm a technical evangelist at Microsoft. During my day job, I work closely with the Azure engineering team and with global partners, and we focus on Azure solutions. This project, on the other hand, is one of my personal projects, so it doesn't really have anything to do with my day job, but it's cool nonetheless. You can get hold of me on Twitter at pbauer. There's my handle. Probably the easiest way to get hold of me. That's always on. So Go is a statically typed language that feels very much like a dynamic language. The thing that attracted me to it was it felt a lot like the scripting languages that I've used in the past, but it's very, very powerful in that it's statically typed. It has a huge collection of core libraries. It also has a huge collection of third-party libraries, and I utilize some of those. The one feature, though, that really sold me was I was looking for a language that could get me a binary across Linux, Windows, and Mac, and Go certainly fit the bill. How many of you have heard of Go? I'm assuming all of you. No? Used Go? Ah, good. Okay, well, I'll give you a gentle introduction and hopefully provide some interesting anecdotes along the way. So what are we going to cover? So the open source project that I'll be covering is a project called ScriptCS Version Manager. ScriptCS it's a way of running C# as a scripting language. And when I was working with this, I was trying to run multiple versions on my machine, and the only way at that point to install them was to uninstall the previous version and install a new version. So I sat down with Glenn Block, who created ScriptCS, and we decided to start on a version manager for ScriptCS. So I'm going to cover off sort of what it is and why I started looking at Go as opposed to the technologies that I wrote it in originally. And that's what the considerations are going to be. I considered a number of options, but I finally landed up on Go, and I'll explain why. For those of you who've worked with Go, you know it's a bit opinionated, like a lot of other languages. Sometimes that can bite you. So I'll walk through how you should organize your project if you're doing something non-trivial. Hello World works perfectly. Once you move beyond that, some things start to bite you if you don't understand them. Package management is also a hot topic. If you come from a world like Node or C# with NuGet, Go might be an interesting place for you. Which languages typically are you guys using? Node or C#? C#, okay. And then I'll also look briefly at some of the language aspects that I really enjoyed, and also some of the tooling that I've been using to help me with Go. So let's dive into the ScriptCS version manager. First of all, we need to start with what ScriptCS is. I sort of alluded to it a bit earlier. It's a way of writing C#. You don't even need to write a package or a namespace. You can literally write code fragments of C# and it will execute like a script. Under the hood, it uses Roslyn to actually to emit the DLLs into memory, and then it will execute like a script. On the Mac and Linux side, we were using Mono to do the same thing. Now, SVM, or ScriptCS Version Manager, I did a Pluralsight course on ScriptCS, and while I was busy doing the course, there were new versions of ScriptCS coming out all the time. And as I said earlier, this often led to me having to uninstall and reinstall, and sometimes I wanted different versions on the machine because each of them had different side effects, and I wanted to demonstrate that. And there was no way to do it easily, so I started the version manager. This allows you to not only install multiple versions on your machine of ScriptCS, you can also link to a a dev build that you're running. So you could check out the script.cs code, compile a new version, fix a bug, and actually link to it and run it as a version on your machine. So let's have a quick look at script.cs, or SVM. So I've got PowerShell here, and if I just do an SVM list, that's going to tell me that I've got 2 versions of script.cs installed on my machine, and the little asterisk next to 0.16.1 means that's the active one. I can also then check all the versions that are available for me to install. So this actually reaches out to an API and does a list and gets the available versions. I actually need to remove some of those, they're a bit old. And then if I do script.cs minus version, you'll see this is actually now running script.cs, and that's actually 0.16.1, which is the one I showed you. So now this is showing it running on Windows. So now to show you running on Linux, I'm actually just going to fire up a Docker container. So this is running, I'm running Docker native on my machine, so it's effectively going to spin up an Ubuntu image. So again, I can just do an SVM list. You can see that's now running. And I can do, and again, now that's running on Linux. So you can see it works exactly the same across both platforms. Now how this actually works, if you just come over to the GitHub repo, can everyone see the writing? Is it big enough? Everyone? Good. Okay, so as I mentioned earlier, to get this cross-platform capability, initially what I did, I wanted as minimal impact on the person installing it as possible. So I've got this concept of a binary, which is the SVM binary, and then the shims are a shim that gets called, that wraps script.cs. So when you execute script.cs, it can check some logic to figure out which version of script.cs it should actually run. So when I was writing each of these, the Windows versions are all written in PowerShell, and the Linux versions are written in Bash. And then, because on Windows you've got 2 console type environments, you've got the command prompt. So there's a CMD, which is actually just a bootstrapper to run the PowerShell. And then PowerShell you could run from a PowerShell command, but I came up against an issue where if you have a script, so if I'd named the PowerShell script SVM and I was in a PowerShell console, I couldn't hook into a bootstrapper. So I needed to actually call it something else and make sure that even from PowerShell, the command, that CMD file was being run, because it's actually bootstrapping. So in the Windows case, it's a little different. So I'm not going to go too much into detail here. I just want to give you a brief overview. But the Bash, I don't think I've ever written this much Bash in my life, but it actually became a large programming language. Well, a large program written in Bash. And then the PowerShell one was also getting quite complicated. As I mentioned earlier, most of my PowerShell looks very much like C#, because I instantiate all the C# objects and to get the capabilities. Now, some of the issues that I came up against here on the Mac, I think Bash at that point was Bash 3, and on Linux it was Bash 4, and Bash 3 didn't have associative arrays, so some of the programming constructs started getting a bit complicated in Bash, and also some of the sorting that I was capable of doing. Like in PowerShell, because you can create objects and sort on properties, some of the capabilities in the PowerShell SVM were a lot more, they were a lot better than on the Bash version, what I could actually do. And this started to show up in the issues. I'll just show you all the bugs that came through. So a lot of these was, it works like this in Mac, but it doesn't work like this in Windows, and works like this in Windows, but it doesn't work like this in Mac. And at that point, it became really difficult maintaining 2 separate code bases. It's almost analogous to in the mobile space where you're running an Android and an iOS separate code bases for the same app. So I started to look around, what potentially could I leverage to move beyond this and have one code base where I could actually write both of these things. So my first consideration was Node.js and NPM. Here we've got a cross-platform language, cross-platform runtime, and NPM gives me the package management, which is awesome. The Azure CLI, the cross-platform interface, is also written in Node, which is why I started here. This was very, very attractive. But then I started thinking, I think .NET Core was starting to make noise at that point. It was still very early days, but I thought maybe this is worth looking at. So I started looking at .NET Core. It also had NuGet, so the package management was catered for, but it was early days, and I then started to look at all the artifacts that would come along for the ride. So you wouldn't just get a single binary, you would get all these assemblies and multiple folders, and it would be this proliferation of assets. Between this and Node, that started driving me to look to another solution. So this is why I ended up in Go. Go was originally written in Google. It was created in 2007, so it's almost 10 years old. It was created as a very lightweight, statically typed language, but it feels like a dynamic language, and it generates a single binary with all the statically linked libraries pulled in. So you may have multiple libraries, but it spits out a single binary, and that binary you can target at different platforms. So you can target at different architectures, x86, x64, PowerPC, a whole bunch of them, and then different operating systems. So how do you get started with Go? Let me just pop over to the Golang website. So it's really easy. Go to golang.org. We've got some very nice tutorials you can just run in the browser. If you go to the documentation, down here there's a learn page. There are tons of books to get you started and to get you on your journey. So if you're just getting going, definitely have a look here. The other great thing, as I mentioned, is that the core packages that come with Go are impressive. So this is a list of all of them. So there's actually a lot of them, and it gives you a lot of capability. Once you, sorry, I wanted to show you one more thing there. On the downloads page. So like Node, you can actually install Go for each of the different platforms. So you've got Windows, Mac, and Linux. That installs on each of those OSs. So once it installs onto your machine, to actually find the binaries, your path is set up with each of these different paths in the different OSs. So on Windows, you have cgo bin and the actual Go executable. So that's similar to the Node executable or the .NET exe in the new .NET Core. And then in Linux and Mac, you've got the bin folders. Go root is also a very important environment variable. This sets up to the installation path of where Go is installed. This is important because all of those packages, the core libraries that I showed you, their source code is sitting in a source folder in this location. So if you want to see how each of those libraries is created, all the source code comes along when you actually create it, and those are used to generate your code. This is probably the most important environment variable in Go. It's called GoPath. It defines the workspace, and this is a source of much of my frustration in my journey, which I'll elaborate on shortly. So GoPath defines the workspace that all of the Go tooling works around. So in your GoPath or your workspace, there will be 3 folders that you need to define. Source is where you write your source code. Packages are where intermediate libraries are compiled before they're statically linked. and then bin is where the final executable gets dumped. So think of that like the debug folder in C# or .NET. So as an example, I've got a source code called hello.go, so that's the file. It's in a folder called say hello, and it's in a namespace folder called NDC Sydney demo 2. And the resulting binary will be say hello.exe. It takes the namespace, it takes the name of the package, similar as in C#. So if we have a look at hello, this is what a Go package looks like. Package main means this is going to be the executable, and then function main means this is the main entry point. And importing FMT, which is the format library, the core library, and that's how you just print. So it's a printf, print to the standard output. So that's a really simple program. That's generating a single binary. Now say we want to do something more complicated. We want to potentially reverse the string. We're going to build another library. So in this case, we would still have our hello go, but we would have a library called stringutil. That would be just reverse.go. When this compiled, it would create a package. So this is the library binary that gets statically linked, and then it still generates the binary on the output. So if we have a look, the hello.go looks pretty similar. We're just now importing our string utility. So that's the full path to that location of the string util. And then we're just going to do a reverse on the string. Don't pay too much attention to the internals of this. It's complicated rune stuff in Go. But this is just showing that if you don't name your package main, then it automatically becomes a library. That's all I wanted you to take away from that. This is also a little bit confusing. When you want to build or create your executable, you run a command called go install. What this does is it builds your packages and then installs the exe into the binary folder, into that bin folder. I think if you're used to commands like .NET build or .NET run or something build, it gets a bit complicated. These two environment variables are also really important, particularly if you're looking at the cross-platform stuff. So Go OS determines the operating system that the binary will be compiled for. So if I change the Go OS variable, environment variable, I can actually spit out a binary for a different platform. And the architecture Go Arch is exactly the same. So you can spit it out for AMD, for Intel, for PowerPC, and ARM. I think there are a number of them. Yeah, so those are the main ones we're going to be looking at in this demo. So let's have a look at a demo. Okay, so here I have created, on my machine, my Go path variable is set to C Project's Go workspace. So this is now where all of my Go code is going to be written. So I'm just going to show you those two files again. So I've got the hello file and I've got the reverse file. So now I'm actually going to compile this and run it and show you. So we do go install. You'll notice here that I don't need to go down the source folder. I'm targeting the actual package in that source folder. So that's the say hello. It's going to generate a say hello binary for me now. Oh. Hang on. That should work. Wrong slashes. Okay, so essentially what this has done now is it's built the binary. So in the binary folder, I've got an exe, and it's going to print it back to front. So now just to show you, I'm still running on Windows. I'm going to now set the GoOS variable to Linux. So now I'm saying I want to spit out a Linux binary. Run exactly the same command, go install. What I should have now hang on. So now I have a Linux binary. And let me actually just push that to the top of the screen for you. What it's actually done is put it into a Linux AMD 64 folder, which is the operating system and the architecture. So just to prove that that is actually a Linux binary, so this is Ubuntu Bash on Windows. This is essentially a Linux shell. I'll run that, and it's spat out exactly the same thing. So now we have exactly the same code base, and just by setting an environment variable, we can actually target two different applications. I mean, two different OSs and architectures. So that all seems really easy. I did mention that GoPath provides pain. If we have a look at the source folder, you'll notice that not only is the project that I've just shown you is in there, but a whole bunch of other projects is in there. And if we go to the package folder, it's proliferated with tons of my experiments. If we go to the binary folder, every single output of every single project has been shoved into the one folder. So this now creates a problem where if you're used to being able to segment your projects into separate locations, it becomes kind of tricky because everything is shared within the workspace. That described the feeling that I had the first time I experienced this. Not happy. So I started looking at different approaches. I wasn't the only person who had started in Go who was moaning about this or looking for alternatives. The solution I eventually settled on was called GB. It's actually written by Dave Cheney, and he is actually from Sydney. And I think he is a co-coordinator of the Go user group in Sydney. If you need to learn Go, read his blog posts and start using these tools because they are actually amazing. So I'll just show you what GB is. It's essentially a nice build tool for Go. So this now allows you to run your entire project in folders, just like you would with Node, with C#. It no longer uses your workspace as a common place for all of your applications. You can actually have your project and your application segmented in a folder. So the easiest way to install it is with Go Get. Go is the binary, as I said, that's installed in your bin folder. We looked at Go Install. Go Get gets packages. It can get them from GitHub or any URL, and will actually install them in the source folder in your workspace. So this is where it starts getting complicated, because every single package you install with Go Get is being shoved into your workspace. So it's conceptually similar to Node, where you have a global space, but you don't have a private space to store the Node modules anymore. This is all in one place. So what I've started doing is all the tooling or all the project or all the machine-wide type of libraries I want to use, I use go-get, and they all go into the workspace. But I've started using GB to actually segment all the project-related libraries into a separate folder. So in GB, projects do not live in Go path. It's actually all segmented, which actually keeps your code a lot cleaner. So the top of the hierarchy is project. Within that, we've got the familiar bin package source. It maintains the same layout so that you're familiar with it. What it adds, though, is something called vendor source. Has anyone used Ruby before? No? There was a concept with the Ruby gems around vendoring, which at the time I didn't really like because we were using real package management like NuGet. But what this does is it will take one of the packages that you get off GitHub or wherever and actually put it into this vendor source folder. So it'll take a snapshot. Again, this is not something I've liked in the past because they're package management sites that you can actually go get packages from. You don't want to be committing packages, and that's what we're always told. Don't commit your packages into your source control. Did anyone hear of the left pad incident in the node world? Yeah. So there was a discrepancy, well, there was a disagreement over a name in the npm repository, and one of the packages got pulled, and there were thousands of other packages that relied on that, and they all broke overnight. So based on that, I'm becoming more likely to actually store external dependencies in here, and that's essentially what this is doing. So GB makes it really easy. It's got familiar language like build. GB build will literally build your solution and put stuff in that project folder. It's no longer pushed into the workspace. Let's have a quick look how this works. So this is what my folder currently looks like. It's the same example we've been running all along. If I run GB build all, that will build everything. I can actually target individual packages and force recompilation of individual packages. So it's actually quite a powerful tool. I'm going to build all, and it actually shows me the packages that it's rebuilding. So it's built the string util package, and it's built the hello, say hello binary. If I run that tree view again, you'll actually see, just push it up a bit for you. Right at the top, we've got a binary again, packages, say hello, and string util. So those are the intermediate binaries that are compiled and will be statically linked. And then they're the packages. So now this is all outside of the workspace, and it's clean, and I can actually wrap that whole thing up into a repo. So it's nice and segmented, which is exactly what we're after. And then just to prove that it still works, still our familiar backwards say hello. So now that we've figured out the workspace problem, the next thing in a cross-platform solution is typically certain functionality may work on specific OSs, and on other OSs you want to target different functionality. So this is where conditional compilation comes in, and you leverage this via build constraints. So it's as easy as at the top of your Go file, you put that command. It's a comment plus build, and then we'll go through what you put after it. There must be a space, an empty line after that, just so that the build system knows that is a build constraint. So if there's commas between two words, it's treated as an and if there's a space, it's treated as an or. So you can build up complex Boolean logic. So this top one says this file should only be built for 386 architectures of Linux and any Darwin, which is Mac OS. And this bottom one here, you can actually have multiple lines. Top line is saying Linux or Darwin, and it can only be AMD 64. that targets a specific architecture. Another very interesting way to do this, if that is not sufficient for you, you can use file suffixes. So if you use any of these patterns on your file names, it will actually target the build system as well. So this is actually an example of something that I'm having to do. Within the version manager, I need to do symlinking of the versions to specific folders. Now on Linux and Mac, I can use the Go symlink library. That same library on Windows uses the symlink functionality in Windows, which requires elevated privileges. So what I used to do in the PowerShell version is I use junctions with makelink, which doesn't require elevated privileges, so that's a better solution. So what I do here is on Windows, I'm using exec.command, which effectively just I shell out to the junction command to actually create a junction, not a symlink. And on Linux and Mac, I use the standard Go library. So here I'm using a combination of these two things. In the symlink.go file, I've got build targets to say for Mac and Linux, compile this for that functionality. And on here, I'm using the symlink_Windows. So this file will only be pulled into the Windows version of the binary. Everyone understand that? Yep. And then package management, as I said, this happened again to me because package management is a bit of a mess. So go get, as I said, this command puts everything into your workspace, which is fine if you're looking for a global workspace like in Node, but if you're not, everything is messed up. Well, everything is pushed into a single space. So I started looking at package managers and I started looking at forums. A lot of people were complaining about the same thing. The last time I looked, there were 20 different package managers that people had attempted to start because there was no industry standard for Go. So lots of people were writing their own. But then the problem you have is the libraries you're looking for may not be in the package manager that you want to use. Yeah, there's one of the ones that you may see a lot is called GoDep. That copies dependencies out of your workspace into your vendor folder, but they're still in your workspace. One I heard about this week was Glide, which is also gaining momentum. It looks really good, but again, it's quite tied to the Go path, which is, I'm still not comfortable with that. So since I was using GB already, GB has a fantastic thing called GB Vendor. So GoBuild has a plugin architecture, and they have a vendor management, so it's third-party library management utility. You can fetch it, update it, list it, delete it, purge it, restore it. So let's re-look at the Scriptsius version manager. So this is now we were looking at the one that was written in PowerShell and Bash. We're now going to look at the one that I've started rewriting in Go. It's still in a branch. Let me just get that checked out. So that's just the GB vendor command. As you can see, if I do GB vendor list, those are all the packages that I'm using in this version of SVM. As you can see, there are quite a few. And those are the actual packages within. GB list will actually list the packages that are mine. So the vendor list will list all the vendor packages, and the list will list all the packages that are mine. So just to show you what this actually looks like, pull it up in code again. Where did code go? So we've got our code in here under source. The command is, with the packages I'm using, command The libraries I'm using expect the exe to be in command, so that's why this structure has been enforced. It's not a Go standard. And then all my script.cs libraries are inside there. This is all the functionality I'm writing. And in the vendor folder, those are all the third-party libraries I've pulled in. The way it manages all of this is with a manifest. So it'll actually show you all your dependencies, show you the link in GitHub that it pulled it from, and the actual revision and the branch. So this is still not proper package management with versioning, but it's getting close where you can actually restore and rebuild and actually have a fixed point in time, and it's separate from all the other stuff in your workspace. If we go back here, I'm just going to do a GB build all on this Go project. You can see it's rebuilding all the stuff. Get this to the top of the screen. If I run the SVM thing, it's looking a little bit more tidy. You can see we've got it there, and then run a command. So this is just showing that I've just compiled the binary. And again, the environment variables work. So if I set it up to be Linux and do a GB build again, you can see that it's actually created a SVM, not an SVM exe. And go back to the Ubuntu, the other one. And in here, so GB actually does a bit of naming. It's no longer in a folder called Linux AMD. It actually renames the binary, just so it's clear all the binaries that are spat out, which architecture they're related to. As you can see, it's exactly the same. So some really cool things around the language that I also found along the journey. If you look at Go code, it is idiomatic. Everything has multiple return values. So if you've come from a scripting background, I come from a long time ago from a Perl background, and there everything had multiple return values. In C#, most thing is a single return value. You can emulate this with a struct or an object. But in Go, you'll always see multiple return values coming back. So an example of this is one of the functions I've written in SVM, is to check if a path that I'm given is a directory. You can see here the OS library, stat, is giving me a file info object. I'm getting the file info and the error back. So if there's an error, error won't be null. If there is an error, it won't be null. So we can do that check and then return. There's another way of looking at this. If you're not interested in one of the parameters, you can use the thing called the blank identifier. And this essentially just swallows the variable, so you don't have to create a variable to contain it. Another interesting concept is something called defer, the defer keyword. What this does is it behaves very similarly to finally in C#. As you can see here, we've opened a file, and defer is often used to close file handles, close network connections. So the thing I really like about this is that you put the defer right next to the open. So it's not in a finally block where you might forget about it. You put it right here, and when this is compiled, defer will always be called when this function exits. So if it exits here, or if there's an error and it exits, this will always be called. But the fact that it's close to the actual open means it makes your code more readable. And then you'll hear that Go has no exceptions. As I said, the guidance is to provide multiple return values. So most of the errors come back as part of that multiple return value stream. Within packages, you should only return errors. You should never throw. There is a way to throw, and that's what the panic keyword is. Panic really just means die. There is a way to recover from that using the defer keyword. So if you panic, it will essentially just exit the function, walk up the stack, and call the defers on any of the functions or the modules above it. As I said, the guidance is do not panic. Do not leak panics across package boundaries. You can use panics within your modules or your packages, but the guidance is a package should always return a value, return an error, just so that everything is consistent. This is an interesting use of defer here, which can actually behave like a catch from Java and from C#. So this defer function will always be called before this main exits, so you can actually catch your exceptions. And then tooling. You may have noticed I was using VS Code. Is everyone using VS Code or Visual Studio? Awesome. It's a really, really great lightweight editor. So there's a VS Code Go plugin, and it gives you everything you need. It gives you syntax highlighting, all the tools. Your mileage may vary because most of this assumes Go path is set and the workspace is there. So most of it works for me. I get syntax highlighting and a bit of functionality, but a lot of these utilities may not work if you don't use Go path or the workspace. You can also configure it. So there's a whole bunch of settings. Typically what I do, right on the bottom there, I'll always put my project path into Go path. So Go path, what I didn't mention right in the beginning is Go path is not a single, it doesn't only need to take a single path, it can take multiple paths. But that's not how you're meant to use it. It's always meant to be a workspace. But for this utility, I put into VS Code settings, which means it stays with this project. It's not VS Code wide. And I actually add the project path in the beginning of the Go path, just so that more things work within the application. I'm not sure if you notice some of the fonts, or I might show you again shortly. Fira code is also a great thing. If you're using Go or any other application that uses interesting fonts, like not equals to, greater than, the comments, what this font does is it adds ligatures, so it'll actually re-render the fonts. Underneath, the ASCII is still the same, the ASCII codes, but the rendering is different. And you can use this with Visual Studio Code. So there's just a selection of what it can actually give you. It makes some of the content actually more readable. And it's as easy as that. In Visual Studio Code, in your settings, your user settings, just add the font family Fira code and the font ligatures true, and that will actually do that for you. So just to wrap up, some of the important takeaways from this are Go is incredibly powerful language. It generates statically linked binaries, a single binary. You can target multiple platforms, multiple operating systems. It's really easy to use. But the things that you really need to watch out for is the workspace. If you have a single project, it probably won't bite you as much. But as soon as you start having multiple projects, the pollution within there starts becoming a bit overwhelming. Thank you. Any questions? No? Yeah.
So I'm new with...
So do you want the mic?
Yeah. Thank you. I'm new with Go. Could you just explain a couple of words? What's the benefit to use Go versus like .NET or Java? What's the key reason why?
So, you have to look at your own use case. For me, my primary driver was to have a single binary. So with With Java, I would have still had all the, well, you may have had jar files, but I wasn't interested in writing it in Java. With C#, I would have had all the additional packages, all the NuGet packages coming out. I actually did consider .NET Native at one point, but it wasn't quite right, and it wasn't quite ready at that point. I still don't know if it quite is. When I looked at it, you could literally only compile a hello world and not much beyond that. Once it is ready, I might actually rewrite this again.
Okay.
Yeah. Does that answer your question?
Yes, it's a case by case, I guess.
Yeah, exactly. Yeah. Anyone else? No. All good.
All right.
Cool. Thanks everyone.